6223. Hail will most likely be encountered: A. Beneath the Anvil cloud of a large cumulonimbus. B. During the dissipating stage of the cumulonimbus. C. Above the cumulonimbus cloud well above the freezing level. The correct answer is A. Hail is most likely to be encountered beneath the Anvil cloud of a large cumulonimbus. Cumulonimbus clouds are characterized by their towering structure and anvil-shaped top, which is formed when the cloud reaches the tropopause. The Anvil cloud extends horizontally from the top of the cumulonimbus and is a distinctive feature of mature and severe thunderstorms. Within a large cumulonimbus cloud, there are strong updrafts and downdrafts of air, as updrafts carry water droplets upward into extremely cold regions of the cloud. The droplets freeze and form ice pellets. These ice pellets can grow in size as they are repeatedly carried upward and downward by the updrafts and downdrafts within the cloud. Eventually, when the hailstones become too heavy for the updrafts to support, they begin to fall from the cloud. Hailstones tend to fall beneath the Anvil cloud of a large cumulonimbus due to their weight and gravity. The Anvil cloud acts as a marker for the presence of the severe storm and often indicates the area where hail is most likely to be encountered. It's important to note that hail can also occur within other regions of a cumulonimbus cloud, particularly in the area below the Anvil cloud, but still within the main body of the cloud. However, the highest concentration and larger sized hailstones are generally found beneath the Anvil cloud. Therefore, encountering hail is most likely to happen beneath the Anvil cloud of a large cumulonimbus. 6224. One condition necessary for the formation of fog is: A. Calm air. B. Visible moisture. C. High relative humidity. The correct answer is C. One condition necessary for the formation of fog is high relative humidity. Relative humidity refers to the amount of moisture present in the air compared to the maximum amount of moisture the air can hold at a given temperature. Fog is a type of cloud that forms near the ground when the air is cooled to the point where it becomes saturated, meaning it holds as much moisture as it can at that temperature. When the air temperature drops, it reduces the air's capacity to hold moisture, and if the moisture content remains the same or increases, the air becomes saturated, leading to the formation of fog. High relative humidity plays a crucial role in fog formation because it indicates that the air is already holding a significant amount of moisture. When conditions such as cooling or the addition of more moisture occur, the high relative humidity makes it more likely for the air to reach saturation and form fog. Fog typically forms when moist air near the surface comes into contact with a colder surface or encounters a colder layer of air. As the air cools, its ability to hold moisture decreases, and if the relative humidity is high, the air quickly becomes saturated. This leads to the condensation of water vapor into tiny water droplets or ice crystals, creating the characteristic misty or opaque appearance of fog. 6225. Radiation fog is most likely to occur under what conditions? A. Warm, moist air being forced upslope by light winds resulting in the air being cooled and condensed. B. High humidity during the early evening, cool cloudless night with light winds, and favorable topography. C. Low temperature / dew point spread, calm wind conditions, the presence of hygroscopic nuclei, low overcast, and favorable topography. The correct answer is B. Radiation fog is most likely to occur under specific atmospheric conditions that include high humidity during the early evening, a cool cloudless night with light winds, and favorable topography. Radiation fog forms when the ground and nearby air cool rapidly through radiative heat loss during the night or early morning. The cooling process begins as the sun sets and continues into the night, causing the ground and air near the surface to cool. High humidity is crucial for fog formation, as it indicates the presence of ample moisture in the air. In the described conditions, the cool air near the surface remains in contact with the ground for a longer time, due to light winds or calm wind conditions. This extended contact allows the cool air to further cool and reach its dew point, leading to the condensation of water vapor and the formation of fog. Additionally, favorable topography, such as valleys or low-lying areas, can contribute to the formation of radiation fog. These topographical features act as natural traps that prevent the cool air from dispersing, leading to the accumulation of fog in those areas. Therefore, for the specific occurrence of radiation fog, the most likely conditions include high humidity during the early evening, a cool, cloudless night with light winds, and the presence of favorable topography. 6226. Advection fog is formed as a result of A. Moist air moving over a colder surface. B. The addition of moisture to a mass of cold air as it moves over a body of water. C. The ground cooling adjacent air to the dew point temperature on clear, calm nights. The correct answer is A. Advection fog is formed as a result of moist air moving over a colder surface. This process occurs when relatively warm, moist air encounters a colder surface, leading to cooling and condensation. When the warm, moist air comes into contact with the colder surface, the temperature difference causes the air to cool. As the air cools, it reaches its dew point temperature, which is the temperature at which the air becomes saturated and cannot hold all of its moisture in the form of vapor. As a result, the excess moisture condenses into tiny water droplets, forming fog. The movement of moist air over a colder surface can happen in various scenarios. For example, in coastal areas, warm, moist air from the ocean may flow over cooler land surfaces. This temperature contrast causes the moist air to cool and condense into advection fog. It's important to note that advection fog is different from other types of fog. It specifically occurs due to the advection or horizontal movement of moist air over a colder surface. Other types of fog, such as radiation fog and steam fog, have different formation mechanisms. In summary, advection fog forms when moist air moves over a colder surface, resulting in cooling and condensation. This process typically happens when warm, moist air encounters a temperature contrast with the underlying surface, leading to the formation of fog. 6227. With respect to advection fog, which statement is true? A. It forms almost exclusively at night or near daybreak. B. It forms when unstable air is cooled adiabatically. C. It can appear suddenly during day or night, and it is more persistent than radiation fog. The correct answer is C. Advection fog, characterized by the movement of moist air over a colder surface, exhibits certain characteristics that differentiate it from other types of fog. Here are the additional details. Appearance during day or night. Advection fog can appear suddenly and occur at any time, whether it is during the day or at night. The formation of advection fog is not exclusively tied to specific times of the day like some other types of fog. It is primarily influenced by the movement of moist air encountering a temperature contrast with a colder surface. Persistence. Advection fog tends to be more persistent compared to radiation fog. It can linger for extended periods due to the continuous supply of moist air from a moisture source, such as a body of water or a moist land surface. This ongoing influx of moist air sustains the fog formation and allows it to persist over time. Triggering factors. Advection fog is commonly associated with weather conditions involving the movement of air masses. It often occurs when warm, moist air is transported horizontally or advected over a colder surface, such as a cold ocean current, a snow-covered area, or a cooler landmass. The temperature contrast between the warm, moist air and the colder surface causes the moist air to cool and condense, leading to the formation of advection fog. Widespread coverage. Advection fog has the potential to cover large areas due to the continuous influx of moist air from the moisture source. It can spread over coastal regions, plains, or other areas where the moist air mass interacts with a colder surface, resulting in widespread fog coverage. Dissipation. Advection fog may dissipate gradually as the temperature contrast decreases or if the moist air mass moves away from the colder surface. Factors such as changes in wind patterns, temperature variations, or the arrival of a different air mass can contribute to the dissipation of advection fog. In summary, advection fog can appear suddenly during the day or night and is more persistent compared to radiation fog. It forms when moist air moves over a colder surface and can cover large areas due to the continuous supply of moist air. Understanding these characteristics helps in recognizing and anticipating the occurrence of advection fog in various weather conditions.